All right, guys, are there any questions on the homework assignment so far? Yep. Now, what we're talking about today is addition, subtraction. So what we're talking about is adding and subtracting rational expressions. Now, to be able to add or subtract rational expressions, we need the denominators to be the same. If the denominators are the same, we add or subtract the numerators. And that's it. So, if we look at the first one here, 7 over 4x plus 3 over 4x. Well, the denominators are and the denominator will stay the same. We're just adding or subtracting the numerators. Here we're going to add the numerators. So we're adding 7 and 3. And 7 plus 3 is? Will this reduce? Yes. Because 10 over 4 reduces to? 5 over 2. Yes. Because if it will reduce, we will need to reduce it. And that's it. So on this next one here, 2x over x plus 6 minus 5 over x plus 6. The denominators are the same. Be x plus 6. So we subtract the numerators. Can we subtract 2x or 5 from 2x? No, they're not like terms. Is there a greatest common factor between 2x and 5? No. So there's no way we can factor it. There's no way we can have like terms on top and bottom. So that's as simplified as it gets. Questions on this so far? So we can go on and do these here. So the next one, 8 over 12x minus 5 over 12x. So we can go on and subtract. 8 minus 5 is 3 over 12x. Will that reduce? 1 over 4x. The next one do have like bases of 3x squared. So we can add the numerators. 2 plus 1 is? 2 gives us 1 over x squared. Because 3 over 3 reduces to 1, so we'd have 1 over x squared. Questions on this here? So do we feel comfortable with these so far? Let's look at number 4 before we move on to the next one. So we do have like bases. They're both x squared plus 1, yes? So we add the numerators. Is there anything we can reduce? Is there a greatest common factor on top? 2. Because top and bottom do have an x squared, but we really have to consider those to be one whole term. The addition really sticks them together, so we can't just cross out the x squareds. But the numerator does have a greatest common factor of 2. And if we factor it out of 2x squared, we're left with x squared plus 2 factored out of 2 is 1. Do we have something in common on top and bottom? X squared plus 1 and x squared plus 1, which leaves us with So sometimes our like terms or what we reduce by won't be just the number, but we can have some variables in common. Questions on this here? Now, not every fraction will be set up so that the denominators are the exact same. Sometimes we have to get the denominators to be the same. And what we use is something called the least common denominator. The least common denominator is the smallest number we can turn both numbers or all the denominators into, so that we're able to add or subtract them. So before we get there, we're going to find the least common multiple or least common denominator. The only difference between least common multiple and least common denominator is that the least common denominator is just talking about the bottom of the fraction. We're using LCM on the bottom of the fractions. So when we look at least common multiple, we're looking for the first thing we can turn both of these into so that they are the same, and we're looking for the smallest one. So the best thing to do for this here is we're going to take 4x squared minus 16 and 6x squared minus 24x plus 24 and factor them down. Because with polynomials, we want to factor them down into smallest terms and go from there. Exactly. So if we look at 4x squared minus 16, both of them have a greatest common factor of 4. And we can factor it out. And if we factor the 4 out, we're left with 4 times x squared minus 4. How will x squared minus 4 factor? X and x, 2 and 2, and then r plus and minus, because x squared minus 4 is a difference of perfect squares, so we have x plus 2 and x minus 2. And that's as factored as it gets. That's fully factored, yes? Okay, let's look at the other one. 6x squared minus 24x plus 24. Is there a greatest common factor? 6. And if we factor it out, we have x squared minus 4x plus 4. Now we do need to factor x squared minus 4x plus 4. So since the 4 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. Factors of x squared are x and x, because those are the only factors. Now for the factors of 4, do we want 1 and 4 or 2 and 2? 2 and 2. And x minus 2 times x minus 2 would be the correct set of factors. Okay, any questions on this so far? Yeah, all right, we could do 6 times x minus 2 squared, but we'll leave it as this here for now. Any questions on what we've done so far? Now we need to find the least common multiple. We need to see what is the first thing, the first number, first expression that we can make both of these be the exact same. Now to do that, we've got to go up. So 4 and 6, we're not looking for a number that's going to be less than 4 or 6. We need to see what is the first number that I can turn both 4 and 6 into. What's the first number that we can make 4 and 6 be? It's not 4, because we're going up. 12, yes? Because least common multiple is going up. Greatest common factor is going down. Because the greatest common factor between 4 and 6 is indeed 2. And again, especially when I first learned these two in middle school, made no sense. Why is greatest common factor smaller than the numbers, but least common multiple is bigger than or equal to? I just remember the first time learning it, it seemed backwards. Why is greatest common factor a number smaller than either number and least common multiple is equal to or bigger than the bigger number? So least common multiple, we're looking for the first number that we can turn both 4 and 6 into. Now, the graphing calculator, if we go to math and over to number, if you look down here, number 8 is LCM, least common multiple. It'll do it for numbers. So we can do 4, 6, enter, and it'll tell us what the least common multiple of those two numbers is. It can only do 2 at a time. So number 9 of 4, 6. So we can do least common multiple or greatest common factor. It can only do 2 at a time, unfortunately. So if we had 3, we could do, say, 4 and 6. And then you can pick that greatest common factor and the other number and see if it is the same or one bigger. So it tells us that the least common multiple between 4 and 6 is 12. Now for the rest of them, we take whichever one or how many they appear, and that's how many we'll need. So if we look at this first one here, it has 1x plus 1, x plus 2, yes? How many does the other one have? 0. So our least common multiple will need at least 1 x plus 2. Because we're trying to make them both be the same, yes? So if one of them has it, the other is going to end up needing it. Because as long as one of them has it, the least common multiple will have it. Now the one on the left has an x minus 2. How many does the one on the right have? So how many will we need? Because we're trying to get them to be the same, yes? One of them already has 1, the other has 2. So this one just needs 1 more, yes? So we only need 2 of them. Whichever one has the most, that's the one we get. Because again, we're trying to get them to be the same, yes? So if I wanted them to be the same, this one over here, to turn the 4 into 12, I just need to multiply it by 3, yes? It has the x plus 2, x minus 2, it's just missing and x minus 2, yes? We can do a similar thing over here. It already has the 2x minus 2, so I can multiply it by an x minus 2, or x plus 2, and 2, and now they are the same. This here, 12, x plus 2 times x minus 2 times x minus 2, is the first expression that we can turn both of these into. First expression we can turn both of them into. And it's the smallest one. Is we could use 3x minus 2s, and they'd be the same. But we have 1 too many. And the issue comes in not so much here with addition and subtraction. Well, it will a little bit. But any expression or number we add over this will end up being factored out later. Any number we add over this will end up being factored out later. Questions on this here? So let me give you an example of this. So if I said 2/3 plus 4/5, what's the first number we can turn 3 and 5 into? 15, yes? So to turn 3 into 15, we would multiply top and bottom by 5. For 5, we'd multiply top and bottom by 3. So this would be 10 15s plus 12 15s, yes? The numerators, 10 plus 12 is 22 over 15. This won't reduce, that's in lowest terms, yes? Couldn't we also, so I'm going to rewrite it again. Couldn't we turn it into 30? Because we could do here, multiply top and bottom by 10, here 6. So this would be 20/3 plus 24 over 30, yes? 30. Wait a minute. So between here, 5 and 5, we had an extra factor of 2, yes? 6 and 6, we had an extra factor of 2. Well, 44 over 30 is reducible, top and bottom by, which will get us to 22 over 15. Because every extra factor we add ends up having to come back out later. And you're looking at this, okay, it's factor of 2. That's not that big a deal. And it's not. 2 is not that big a deal, but if we're adding an extra x plus 2. On top and bottom, we'll have to factor it back out. So instead of having a linear x plus 3 on top, what's supposed to be the top, we add that in. See here, 2. We get this instead, because it's going to be multiplied back in. It's not going to always be this case, but there's a good chance we're going to have to pull that term back out. Any term we go above it, we're going to have to pull it back out. Does that make sense? And it'll make more sense as we're working through these. So we'll look at another one of these here. And personally, I like doing greatest common or least common multiple or least common denominator, where we have these polynomial expressions over monomial terms or number terms, because I find it easier to find these once we factor them. Now 6x squared minus 54, is our greatest common factor? 6. And if we factor it out, we're left with x squared minus 9. X squared minus 9 is one of the ones we like, yes? Difference of perfect squares. So what times itself is x squared? Well, that's x. What times itself is 9? So we'll get x plus 3 and x minus 3. 9x squared minus 54x plus 81. Greatest common factor of 9, which will give us x squared minus 6x plus 9. Now, when we factor x squared minus 6x plus 9, since the 9 is positive, the signs are the same and they match the sign of the middle term. So negative and negative. Factors of x squared are x and x. And factors of 9 are 3 and 3. So we have x minus 3 and x minus 3. Questions on this so far? Now, least common multiple, least common denominator. Another way to think of it is we take whichever one has the most of that term or that number to a power. Because if we think of 6, really in prime factorization, writing it as a product of primes, it's 2 times 3. That's as small as we can get it, yes? 9 is what? 3 times 3 or 3 squared, yes? So if we look at 6, 6 has how many 2's? 1. 9 has how many 2's? So we'll need how many 2's? 1. And we can do this on a calculator here in a minute, and we can see how this works. Now 6 has how many 3's? 9 has how many 3's? So we take whichever one has the most. 9 has. 6 only has 1, so how many do we take? So we can say 3 squared. 3 squared is 9 times 2 is. So if we look over here, nine and 6 is 4. I could just go 6, 12, 18, 24, 30. Do 9, 18, up. Just do multiples of 6, multiples of 9, and see which is the first number that crosses or is the same. That's the one we take. Does that make sense? So from each one we look at, we're taking whichever has the most of that factor. Since 6 had the most 2's, we take it from that. Since 9 had the most 3's, we take it from that. Same thing with our parentheses. Looking at the 2, so we can start with x plus 3. How many does the first one have? How many does the other one have? So how many do we take? 1. The one on the left has 1x minus 3. How many does the one on the right have? So how many do we take? 2. That's it. Now, the way that I like to think of this sometimes, not so much with the numbers. 9 and 6, we'll work through, get that. I look at the one, say, on the left. I just pick one. X plus 3, x minus 3. I take it all. I take both of them. We take x minus 3 and x plus 3. Then I look over at the other one and see, what does this have that this one didn't? Well, this has an extra x minus 3. I put it in. And we're done. That's why I like having the factors. I think it's easier because I grab all from one, look over the other, see what it has that I don't have already, and add it in. Does that make sense? Because we're just trying to make them be the same in the smallest possible set of terms. Be ready for the next one. All right, 5x cubed and 10x squared minus 15x. I think this is the next one, yes? Okay, good. Can we factor 5x cubed? No, that's as simplified as it gets. So we look over at 10x squared minus 15. Can we factor it? Because 10 and 15 do have a greatest common factor of 5 we can pull out. In between x squared and x, we can pull out n x. So 5 factored out of 10 leaves us with 2. And we factor an x out, we have 2x minus 5 factored out of 15 is 3. And the x comes out completely, yes? Okay. Least common multiple. So we have 5x cubed and 5x times 2x minus 3, yes? So we have 2 5s on the, 1 5 on each on the outside, yes? So the easiest one of the day, what is the first number I can turn 5 and 5 into? 5. They're already the same, so I don't have to do anything to it. Least common multiple between 5 and 5 is 5. Okay. Now we're looking at x cubed and x squared. The one on the left has 3, the one on the right has 1, so how many are we going to take? 3. Because with single terms, we're trying to get them to be the same. We don't go down, we always try to go up for them to match. Since one has 3 and the other has 1, we can get the 1 to be 3 by multiplying. Questions on this here? So we're trying to get them to be the same. So this x, I can multiply by x squared. And x squared times x is x to the third. They're now the same, yes? So this here is going to be what the final answer is. So when we get them to be the same, so it's not so much looking at what do we multiply them by, but when I finish multiplying them by whatever they need, this is what it's going to finish. This is what it's going to look like at the end. Does that make more sense? Yeah. Yeah, so here we would need x squared to get them to be the same. This one, what is it missing? So we'd have to multiply by 2x minus 3, which means when they're all the same, the least common multiple will be 5x cubed times 2x minus 3. Does that make more sense? And again, the reason I like just sets of parentheses, because it's really just visually looking, which one does it, what does this have, what does this one have, how can I get them to be the same? I think when we start looking at monomials, these kind of here, you're having to piece more parts together than it is just look. Questions on this here? We good with this here? So we want to find the sum of 7 over 9x squared plus x over 3x squared plus 3x. So the first thing I would do, we're not going to mess with the numerators. We need the denominators to be the same. If we're going to add or subtract, we need the denominators to be the same. So let's factor them. 9x squared is, well, 9x squared. There's no way to get it simpler than that. Now, 3x squared plus 3x. Is there a greatest common factor between these two here? 3x. If we factor 3x out of 3x squared, we're left with x plus 1. Because the 3x factors out completely, so we're left with 1. 3x out of 3x squared leaves us with just x. Questions on this here? Now for us to be able to add or subtract, we need the denominators to be the same, yes? And this here, I think, is a little bit easier than actually finding the least common multiple, because we're looking mainly at the denominators. Over here we have 9, and here we have 3. What is the first number? 3 and 9 are the exact same. Because 9, yes? Because 3, 6, 9. So if I multiply the one on the right by 3, 3x times 3 is going to be 9x, yes? 3 times 3 is 9, so we have 9 and 9. Those are the same, yes? The one on the left has x squared, the one on the right has x, yes? So we need them to both be what? X squared, yes? So we have to multiply the one on the right by x, yes? I have a feeling at least one of y'all noticed the x over x on the one on the right. Yes? Now, there's nothing wrong with reducing that. This x over x. But if I look over here on the left, I have an x squared, yes? Which means the one on the right is going to have an x squared, yes? So we could reduce it, but then we're going to have to multiply it back in. Does that make sense? If this had just been 9x, we don't have to do anything anyway. So sometimes it's helpful to reduce, sometimes it's not. I would wait till after we multiply. Does that make sense? Okay. So we have 3x times 3x, which would give us 9x squared on both, yes? Is there anything the one on the left is missing that the one on the right has? X plus 1, yes? So the one on the left, we're going to have to multiply top and bottom by x plus 1. Now, before we do the numerators, I want to do the denominators first. So x plus 1 times 9x squared. Well, that's just 9x squared times x plus 1, yes? Not too much. The one on the right, 3x times 3x. 3 times 3 is 9. X times x is x squared, and we still have the x plus 1. Were we able to make both denominators be the same? So now we can add the numerators after we finish simplifying that. Now I will say this. Do not actually multiply the denominators out. Because if we have something in common on top and bottom, it's going to be good to have it in factored form. Yes? Because the only way we can really simplify is if we have it in factored form, that multiplied form. So we'll leave it as this here. The numerators, on the other hand, we're going to have to multiply it out. So 7 times x is, 7 times 1 is, plus 7. 3x times x is, 3x squared. Now we can add the numerators together. Now, especially with subtraction, be careful because of our sign changes. Here, since we're adding, we're not going to have a sign change. So really we can say that we have 3x squared plus 7x plus 7 over 9x squared times x plus 1. Questions on this here? So before we finish this up, is there a greatest common factor in the numerator? Is there a number or variable that will go in all three? No. Will it factor? It doesn't look like it might, but we can check b squared minus, or the square root of b squared minus 4ac, because with quadratics, if this comes out to be a whole number, then it is factorable. So we'd have 7 squared, we'd say second square root of 7 squared minus 4 times 3 times 7, which is a domain error. It means the number inside the radical is imaginary, or is a negative, which would be an imaginary number. So that there's the final answer. Now the reason we're looking at factoring it, because if it did factor and one of the factors was x plus 1, then the x plus 1 and x plus 1 would cancel. Questions on this here? Okay. We're going to